With volume and surface area, we are going to be using a lot of formulas. So the main thing with your formulas is that you make sure your units are all the same. So sometimes you might have to convert. So I've put the conversions in there just in case you forget. So remember, if you're going from, millimeters to centimeters, so if you're going from millimeters to centimeters, you'll divide by 10. So you can look at that. There's a few other little area conversions. Be careful when it's not the same when you're going, say, from millimeter squared to centimeter squared. You actually are, when you're talking about an area, you're dividing by 10 squared, okay? So just be careful with that. And then these ones down here are probably pretty important, because sometimes with the volume, they'll ask for milliliters or liters, and your measurements are in centimeters. So probably the most common one is that 1 centimeters cubed equals 1 mil. So if you think about, you've got a 250 mil can of Coke, say that like that is actually 250 centimeters cubed. Okay, it's just sort of 1 for 1. So with surface area, obviously you can follow the formulas, but it's really important to think about what they're actually asking, because sometimes they might not be asking for the area of, like, say it might be an open cylinder. So say for this example here, we've got a cylinder. It's giving me the formula for a full cylinder. So the surface area is always finding the area of the faces. So you can see here, the cylinder has 2 circular faces. So here in the formula, they're working that out. So if you look, the surface area of a cylinder, it'll say 2 pi r squared, because that's that bit there, those 2 bits there. And then if then you've got the bit in the middle, say this bit along here. Okay, so that's here, and it's given. Now if you cut, just to show you, if you cut, like say you cut your can or your cylinder, if you cut it down the side like that, you will produce this rectangle. It'll produce a rectangle piece like what we see here. And because you cut, the edge bit of the rectangle is actually going to be the circumference. So you can see here, this 2 pi r, that's the circumference of a circle. And then you would times it by however long this cylinder is. So that's why there's these parts in the formula, the 2 pi r and the L. So why do I tell you that? Because if you had, say, if they asked you, you had an open cylinder, so they might say, here's, you've got a glass, and it's open at the top, and they say find the surface area. Well, the surface area will just be, there's only 1 circle down the bottom, so you might go, it'll be pi r squared plus the 2 pi r times L. So it'll still have that middle bit and things like that. So you could be just really careful with what they're asking. So here, down here, if you've got the triangle, so often this could be a tent, and sometimes, or they'll say it's a sunshade or something like that. So they might not use the base might not be included. So you could be really careful with the questions. But you can see when you break this up, you have all the different sides. So these 2 triangular ends were there, and so you could find the area of a triangle and times it by 2. This back piece at the back is given here. Okay, then you've got, say, the floor down the bottom, that's given there, and then maybe the slanting top part is given there. So you just got to be careful. All easy because they're all rectangles and triangles, but you just break it up to what you see. Okay, so volume is a different now. So volume, or sometimes they might talk about capacity. It's always the area of the face of the object times the length of it. So if I say for example, so you know, like if you had a rectangular or a square like this, a rectangular block like that, and say that was 2 and that was 2 and this was 8, you can always find the volume. First you find the area of the face, which would be 2 times 2, and then you times it by the length of it, which would be 8. So we often say volume is the area of the cross section, the face of it, times the length. So in examples like this, when it's got a weird shape that you wouldn't know how to find the area of, you just simply, they're telling you. So they told me the area of the face was 120 millimeters squared. So I'll times it by the length of it to get the volume. Okay, and that would give me the volume, which will be millimeters cubed, the answer. Okay, here the same, they gave you the area of the pentagon, and you would times it. If you're finding the volume, it'd be that 22 times 13. Okay, and the answer would be centimeters cubed. All right, so here's a couple of exam questions, so let's do these. And it says a water tank in the shape of a cylinder with a hemispherical top. So a hemispherical top means half a sphere or half a ball, is shown. So they want to find the volume. So I've just sent you today some formula sheets, and so if you want, here's the sphere, so we want half of that. Okay, so we're going to use half of that, and then we also want the cylinder formula. I'm just grabbing them to show you. So we've got the cylinder formula here. Okay, so if I'm finding the volume, I'm going to write down what I've got. I've got half a sphere plus a cylinder. Okay, and then you'll write in the formula. So half, and a sphere's volume is here. So it's half times 4 pi r cubed over 3 plus the volume of a cylinder, which is here, pi r squared times height. Okay, we've got given the radius here, 2, and we're given the height, which is 5. So you can plug all of that into the calculator. 2 cubed, be careful that's a cubed, plus 2 squared times 5, and we'll get an answer. Okay, I got the volume to be 79.6, so meters cubed, so I'm going to go with 80 is the closest. Okay, that was question 5, so it's a bit more. With this one, question 1, so early on in the exam, is going to be pretty easy. Find the area of the shaded area. So really you've got, the area is going to equal, if you had the area of the triangle, the full triangle, and you minused the area of the square. So a triangle's formula is half base times height, and a square is length squared. So if I type all them in, it'd be a half 12 times 10 minus 5 squared. So we get, what's that, 60 minus 25, which is equal to 35. Okay, so that one's question 1, pretty easy. And now down here, they're asking for the volume of this silo. So that's what a silo looks like, a cylinder with a cone on top. So you can just follow your formula sheet. So I know I've got the volume will equal the volume of a cone plus the volume of a cylinder. Okay, so the cone's volume is there, where you go 1/3 times pi times the radius squared times the height. So that's the height of the cone. And the radius is going to be, what's the radius? The radius will be the same for both of them. It's when you go from the center out to the edge. What's the radius in this example?
5.
Good, 5. So we'll have 1/3 times pi times 5 squared times this is the cone's height, which is 1.8, plus the volume of a cylinder, which is pi times the radius squared times the height, which is 16, and we plug all that in. Okay, so I got that to be 1304 if you round up. So there you go. All right. This one is question 8, boys, in the exam. So that means it's supposed to be one of the more challenging ones, or maybe not more challenging, more steps to do. So let's have a look. The slant of the cone has a radius of 2.5 as shown in the diagram. The slant has an edge of x. So they've said this slant side is x. And they've said the whole thing has a volume of 36 centimeters cubed. Now, they said the surface area of this cone can be found using this rule, the surface area, like that. So you can see here we have x is in the question, is in the rule, sorry. So to find the total surface area of this cone, we're going to have to find x first, okay? Because we don't have that. All right, so what I'm going to do is I'm going to try and use this right angle triangle in here, like that, to find x. So I'm going to go, all right, I've got this triangle. I know this is 2.5. This is x. Now, I probably need this bit too, which is the height. And I can't get the height either. I don't have the height either. So what I'm going to look at is what other piece of information do I have? I've got this volume. Okay, so all right, I'm going to write that down. So volume equals 36. But I've got a formula for volume. So I know that 1/3 times pi times the radius, which I have, times h equals 36. And with that, because the volume, I can find out what h is. So I can go solve and comma h. And let's find out what the height is for that. Okay, so I've got h to be I'm just going to say 5.5. So now I can use that up here and I can find x. So x is the hypotenuse. So I can go 5.5 squared plus 2.5 squared, and you can do solve again and comma x. And so this is where I often find it a bit better if you're on your calculator, if you just keep using the solve function, even if you are quite good at your algebra and stuff. It's only because it'll store it the way you're putting it in your calculator, and if we make a little error when we check our work, we can quickly adjust. So I got x to equal 6.04. So now finally I can answer the question down here. The surface area equals pi times the radius, which is 2.5, times the radius, 2.5, plus 6.04. Okay, so times, okay, so I'm just working that one out. And I get 67.08, so I'm going to say approximately 67. Okay, all right. These next ones, when you pick up your notes or you get your notes, you're going to see we have these. I just have popped them in and they're showing you the working out with them. So they wanted to find the total surface area of this shape here. So what they're showing you is it actually is you've got the cylinder. It's like having an open cylinder, really. So the surface area is actually an open cylinder. So what I mean, this bottom bit we have, so this is where it will only be pi r squared plus the surface area, sorry, will be pi r squared plus the middle bit, which is 2 pi r times the height. So you will see that here, that's the cylinder there. They've worked that bit out there. Now, the top bit has a sphere, half a sphere. So you just want the half the surface area of a sphere. So that's, if you times that by a half, so a hemisphere surface area is actually 2 pi r squared. And they've just halved it anyway. They've shown you there and they've worked that out. So they're just good to have, and they're showing what to be careful of. This one, find the volume. We've already done that, where you put a half a sphere on top of a cylinder. And this one with the tent, so we just had to be careful. It asks you that they just want to paint the outside walls and the roof. So really you should just break it up. You've got these 2 roof panels, so they would be, and then wherever they are, and then you've got your 2 end triangles, which they would have times by 2. Then you've got 2 sides, those sides, and then you've got, say, those 2 sides as well. They don't want you to paint the floor, so you've got to break them all up and find it, and they've done that. Okay, here's a tent. So they've got, you've got to find it, and I don't think whether they want the base. They said including the base down here, so hopefully in the question they'll tell you. Okay, so you've got a square base on the bottom, you've got 2 half circles which would make a full circle, then you've got like half the cylinder along there. Yeah, so you look for that. All right, okay, so Kalita manufactures face cream. The cream comes in a cylindrical container. The area of the circular base is 43 centimeters. So they said the circular base, the area, so the area of a circle is pi r squared, and they said that equals 43. And the container has a height of 7 centimeters as shown. Okay. So the diagram below shows the dimensions of the shelf that will display these containers. The shelf will display containers in a single layer. Each container will stand upright on the shelf. What is the maximum number of containers you can fit on the shelf? So if they're going to sit on the shelf upright, they're going to take up the diameters, so the diameter space, if you think about it. So the diameter will be, both ways. So really we're going to have circles along the shelf like that. So if we count up and we get this 74 and we divide it by the diameter of 1, we're going to find out how many we can go across. And if we go, go across, and then if you divide the other way, go across, and then if we go and we divide 37 also by the diameter, we'll see by the diameter, we'll see how many we can go along there as well. So we need to find the diameter, which is actually equal to 2 of the radius. So I can use this formula here to find the radius, because I could do solve pi r squared equals 43, and I'll go comma r. So I work out that the radius is 3.7. So therefore the diameter is equal to 7.4. Okay, so if it's 7.4, if you do 74 divided by 7.4, it means we can get 10 across here. That'll equal 10. If I do 37 divided by 7.4, I end up with 5. So I can get 5 down along here. So if you look, if you just cut off that bit, so this bit here would be 10 by 5. So we get 10 by 5 in this area there. And if you think, if I've cut this off and I've said this is 37, so remember we can get 5 along here, and this is also 37, so I can get 5 by 5, so plus 5 by 5. So in total, what's the maximum I can get? That would be 50 plus 25. So the maximum I can get on the shelf is 75 containers. Okay, each shipping container is in the shape of a rectangular prism. Each shipping container has a height of 2.6 meters and a width of 2.4 and a length of 6 meters, as shown in the diagram. One shipping container is used to carry barrels. Each barrel has a shape of a cylinder, 1.25 meters high, the diameter of 0.73 meters as shown. Each barrel must remain upright in the container. So what is the maximum number of barrels that you can fit in a container? So you got to think they're going to be stored upright like that, and if possible they probably can be stacked on top of each other, but we have to see if that's possible. So they're saying they're 1.25 high and this shipping container is 2.6. So if we do 2.6 divided by 1.25, what do we get? Okay, we get 2.08. So we've got to round down because we're not going to have a lid. So we know we can get two stacked on each other. So we can have whatever the two on top, one on top of each other. And then we have to, so we know the height, it'll verse the top. But now how many can we get across like that? And when we're thinking about that, that would be the diameter. So I've got the diameter, how many can I fit across, which would be 6 meters. So if I do 6 divided by the diameter, which is 0.73, I get 6 divided by 0.73, I get 8.2. So therefore I'm going to say approximately 8 across. Now remember, they're also going to stack along that way. So we need to see how many can go across that way, which would also be 2.4 divided by the diameter. So we get 2.4 divided by 0.73, we get 3.2. So we're going to say approximately. We have to round down all the time for this, 3, because we can't put a little half barrel or whatever. It's just going to be a full one or nothing. So we can get 8 across here, and then we can get 3 across here. So one row of them. So one row on the bottom would be 8 times 3, which equals 24. But remember, we can stack another stack on top. So if we times that by 2, we'll get 48. So what's the maximum number of barrels? Is 48 barrels. Okay, so a cake is in the shape of a rectangular prism as shown. The cake is cut in half to create 2 equal portions. The cut is made along the diagonal as represented along the line. The total surface area in square meters are one proportion of the cake. So let's draw what our piece will look like. We've now got a triangular prism here. So we've got the sides of the cake. Sorry, this is a pretty bad diagram, but there you go. You got those sides, and so if you break it up. So let's break it up into what we've got. I'll highlight it on here. So we'd have the top triangle, and that would also be down the bottom, wouldn't it? We'd have a bottom piece of the area. So I'm going to say we've got the triangle face, and we've got 2 of them. Okay, now we know the triangle face has a 6 and has an 8, so we've got that. because I'm using this 6 and 8. Okay, so we can find the area of those that using a half base times height. Okay, so we've got that bit sorted. We then have this, we've got this square piece at the front for the surface area. So if I drew that bit, I have this square bit, which is going to be a 6 by 6. So 6 by 6. And then, so we can say 6 times 6 for the area of that bit. And this one was a half 6 times 8, that bit. Okay, we then have this side panel here, okay, which would be that bit there, okay, which is also a square. So if I draw, or rectangle I should say, and we know that that's 6, so we've got a 6 by 8, so we're going to add the area of that bit. Now we've also got, which is just a little bit hard to see, we've got this on, I'll just rub out all my things and I'll try and draw it in to show you. So say we've cut along there, we actually have this, the face bit of the triangle, so it's sort of down underneath there, you can't see it, but we can see too, that would be, it is a rectangle piece. So you've got like that, and it goes across there like that. So we do have this rectangle piece, okay, where we've got, we know this is bit 6, but I need to know this diagonal bit there, which would be X there. So I don't know, which is also X down there, which I don't know what it is, but I can use this bottom triangle, the one that we had 8 and 6, and I can use this X, so that's really X. We can use that and use Pythagoras to find out what X is. So I can say X squared equals 6 squared plus 8 squared, and I can do solve comma X, and I can find out what X equals. Okay, and we get X to be 10, so that's nice. So then this area, finally we can work that out, would be 6 times 10. So we're going to add all these up. So I have this one, a half times 6 times 8. So that's going to be 24, plus this one, which is 36. Okay, plus this one, which is 6 times 8, which is 48, plus the 6 by 10, which is 60. So if we add all those numbers up, we get 100. So we get 24. Oh, we've got 2 of these, sorry. So that would be 24 times 2. So that's actually 48 plus 36 plus 48 plus 60. So what I'm saying, this was a triangle, we had 2 of them. So if you add all them up, we get 192 there, 192. All right, so that was question 8. It's supposed to be a biggie, and it was. This one, question 3. An ice cream dessert is in the shape of a hemisphere. The dessert has a radius of 5 centimeters. The top of the dessert is covered with chocolate. What is the total surface area in square meters that is covered in chocolate? So really, you only have half the sphere, because you're not doing the base, the square base. So it's just half a sphere surface area, which is a half times 4 pi r squared. So it's going to be 2 times pi r squared, which is 2 times pi times the radius psi squared. So I get 2 times pi times 5 squared, and that equals 157. So 157. Okay, a golf ball is spherical in shape and has a radius of 21.4 as shown in the diagram. Assume the surface of the golf ball is smooth. What is the surface area of the golf ball shown? And correct to your nearest millimeters. So they've given you the measurement in millimeter, so that nearly means to the nearest whole number in this case. So we want surface area. So I've gone to my formula sheet and found it. So surface area equals 4 times pi times the radius squared, which would be 4 times pi times 21.4 squared. And we're just going to go to the nearest whole number. So if I do that on my calculator, 4 times pi times 21.4 squared, we get 5,755 millimeters squared. Okay, and then it says the golf balls are sold in a rectangular box and contains 5 identical golf balls as shown below. What is the minimum length of the box? So if you've got the radius of 21.4, really you think about it, you've got how many radiuses? You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you've got 10 balls, if you've got 5 balls, you've got 10 radiuses. So it would be 10 times the radius would be the minimum length. So 10 times 21.4 equals 214 millimeters. And it said in millimeters, so I'll leave it at that.